Hello, this is Ms. DB, and in this video we will talk about Chapter 10, Section 8. This is the worksheet on spheres. So they saved this section for the last part of the chapter. We have to learn how to do the volume and surface area of a sphere. There's a formula for volume, which is 4/3 pi r cubed. So you find the radius, take it to the third power, multiply by pi, and then multiply that by 4/3, which is the same as multiplying by 4 and dividing by 3 if you prefer. This can also be written as volume equals 4 pi r cubed, all divided by 3. You might see it like that at some websites or in some textbooks. So there's a couple examples. These are pretty straightforward. A hemisphere is a half of a sphere. So you could take volume equals 1/2 of 4 pi r cubed. But what is 1/2 times 4? It's 2. So the volume of a hemisphere is given with the formula 2 pi r cubed if you want, or you can just always remember to take half of your answer for the volume of a sphere. In number 1, you're going to take the volume of a sphere with a radius of 5. In number 2, they give you the diameter. So don't forget to find the radius because the formula calls for a radius. If you use 16, you would get an answer that was too big, much too big, because you're cubing the radius. Here's one with a hemisphere. So remember that a hemisphere is half of the volume of a sphere, so you either have to use 2 pi r cubed or just take half of your answer for the volume of a sphere. Now number 4 is a little bit different. They ask us to find the radius and then they give us the volume. So I wrote a hint here that you should start by writing the formula, which is volume equals 4/3 pi r cubed, and then we'll replace the parts we know, which is that the volume is 7,776 pi. So that will go on this side for volume, and then that is equal to the rest of the formula. We'll just leave as it is, pi r cubed. Now, first thing that I'm going to do is I see that I have a pi on the left side and a pi on the right side, so I'm going to divide both sides by pi. That means it cancels on the left and it cancels on the right. So I get the simpler formula of, I put a 7 here instead of a 6. A 7,776 is equal to 4/3 r cubed. Now you might say the next step would be to divide by 4/3, but dividing by a fraction is the same as multiplying by its reciprocal. What's the reciprocal of 4/3? It's 3/4. So we're going to multiply both sides by 3/4. And then on the right side, those will cancel. The fraction 3/4 times 4/3 is just 1. So if you take 3/4 times 7,776, it will equal r cubed. Let's go ahead and find what that is. So r cubed would be, let's see, equal to 7,776 times, now how do you times something by 3/4? I can times it by 3 and then divide it by 4, or I could have multiplied by 0.75. So I get 5,832. 5,832. But that's r cubed. I want r. What's the inverse operation to cubing a number? You know how if you have r squared, you could take the square root of it to get r. But we don't have r squared, we have r cubed, so taking the square root won't work. What we need to do is take the cubed root. So we need to take the cubed root of r cubed. Now it really depends on your calculator how you'll do that on a calculator. I can see that on my calculator I only have square root. If I go to the inverse functions, I do see right here, that's the cubed root right here. So it might look like that on your calculators where you have, it looks like a square root with a little variable inside there. Now, I know that the cubed root of 27 is 3, because 3 times 3 times 3 is 27. I'm going to practice using this key to see how I do it on this calculator, because I've never used this calculator. Okay, I'm obviously not cleared out of everything. So if I do 27 and then click this, nope, that's not going to work, because I think I have to type the 3 first. And now it says 3, well, I don't know for sure. That didn't work. So I have to do 27, then this, then the 3, and then I get my answer. All right, so I have to type in my number, 5,832, then the root, and then the 3. And it says it's 18. I'm going to check that by just going 18 to the third power. 18 to the third power is equal to 5,832. So I know now what r is equal to. R is equal to 18. All right, then we look at surface area of spheres. The surface area of a sphere with the radius r is s equals 4 times pi times r squared. So pretty straightforward. In the first example, you're just given a diameter. You will take that times 1/2 to find the radius, and then just plug it in and solve. You can leave your answer with the pi in them by just taking 5 squared is 25 times 4 is 200, and then putting the pi. And then this one is a little more complicated. They give us the surface area, and they want us to find the volume. So we'll use the given surface area, divide both sides by pi, 144, then we would divide, they really jump to that quick, don't they? 144 will equal 4r squared. Divide both sides by 4. Let's see, that is, I think it's 36, but let me just check. Yep, that is 36. And then we would take the square root, because this is r squared, into onto squared, the power of 2, you take the square root. So then we have what r is. So now the problem is just find the volume of a sphere with the radius of r. So you've got a sphere, and it's got, I can't draw spheres very good, but it has a radius of 6. So you would use the formula for volume, and then go ahead and plug in 6 for a radius. Okay, number 5 is just straightforward. Use your formula. Number 6, you have a diameter, so you need to take half of that first, then use the formula. Number 7, we only have a half, so we are going to take, to find the surface area of a hemisphere, you'll take half of the formula for the surface area of a sphere, so half of 4 pi r squared. That will give you the lateral area. But added to that, we will also have to find the area of the circular base, because that is showing, and that is part of it. So pi r squared. Now remember that this is the diameter, not the radius, so you have to first take half of that to find the radius to use in the rest of the formulas. Number 8 is just like the example we just looked at. You're going to write the formula for surface area, and then you will put this in for S, and then you'll divide by 4. Oh, you can cancel out the pi's, divide by 4, and then take the square root to find r. Once you know what r is, you'll find the volume by doing the formula for volume. And then we talk about changing dimensions. Here's an example where they want to know how the volume changed if all of the original dimensions are tripled. So they do the original, and then they triple the dimensions, which is only 1. So 3 times 3 is 9, so they tripled that. And then they divided this, and they found that the volume is multiplied by 27. It'll be 27 times as big. So as expected for volume, if you change a dimension by x, then the volume will increase by that amount cubed. For surface area, it will only increase by x squared. So whatever you multiply your dimensions by, square that amount to see how much the surface area will increase by or change by. So you have two problems to do with both surface area and volume. If you want, you could go ahead and find the volume and surface area of the original and then change the dimensions the way they tell you and then compare them by dividing the new divided by the old and see what you get. Or you can use the rule and say how the surface area will change and how the volume will change for each. And then the last problem is using a composite figure. In this example, you're asked to find both the surface area and volume of this composite figure. In step 2, in order to find the surface area of the cone, you have to use the Pythagorean theorem to find the slant height. They're giving us that, oh no, they're giving us the slant height, sorry. So it's to find the volume of the cone. They give us the slant height as 25. They use the Pythagorean theorem to find the height of the cone, which you need for volume. So you had everything you needed for surface area, but you needed another part for volume in this one. In your example, you are, let's see, we've got the height, we have the radius. I think you have everything you need to find the surface area and volume of this figure. And there's some hints there about how to find the lateral area. And there's only one of these problems to practice working on. All right, so that's it for today. If you have any questions, remember, come to my office hours or when I'm in the ASC room, or email me, and we can also set up a different time to meet if my office hours don't work for you. Thanks a lot and have a wonderful day.